Hello guys, welcome to Java Developers YouTube channel. Today we are discussing the problem number 7, which is a perfect number. Already we had been discussed uh, regarding the perfect number in the problem number 4. But if you want some sort of information regarding the range, go and refer the problem number 6, which is a range of prime numbers. Okay, and just open the workspace. Okay, if you take the number 6, what is the perfect number? Let's understand that. And what are the factors? Basically, the sum of factors equals to the given number. Then you can say that the number is a perfect number, excluding the given number, right? Yeah. What are the factors of 6 from up to 5? Because from the definition, you can see that we should exclude the given number and we have to do the sum of its factors, right? 1 is the factor, yes. 2 is the factor, yes. 2 3 is a 6. 3 is a factor, 3 2s are 6. And 4 is the factor, no. And 5 is the factor, no. If I do the sum of these three numbers, which is 1 plus 2 plus 3, that is equals to the given number, you can say that the 6 is the perfect number. Okay, just write the code for that. And here, just like the prime numbers range, we are taking the two for loops for the same kind of problem. I mean, it's the same in procedure. Okay, let's take the for loop. Just int of I is equals to 1, and I should be iterated from 1 to the 100 and I plus plus. Okay, and initially the problem deals with the sum, right? We need to find the compare the sum with the check with the given number I value. If the I is at somewhere like 6, if the sum equals to 6 and I is equals to 6, right, then you can say that at that point of view 6 is the perfect number. So that I was taking the, and let's take int of j is equals to where the j has to run. Let's take 6, right? Where is the I is at somewhere like 6, and whether I have to check this present 6 value is the perfect or not. Okay, and how the j value will work right now? It has to iterate from 1 2 3 4 5 6. That means j has to start with the 1 and j has to end with it should be less than I. Okay, from the definition, right? J is equals to 1 and j must be less than I and j plus plus. Okay, this is a code for that. Okay, how you find the factors? If I modulo by j, which is double equals to, okay, I modulo by j, which is double equals to 0, then what I have to do right now? Okay, let's understand this step. Like if I have taken the 6, right? What is the first condition? It was starting from the 1, right? Yeah. That means 6 by 1. Okay, that will leaves the remainder 0. Yes, of course it leaves the remainder by the 6 times, right? So what I have to do right now? We need to add that to the sum, right? Sum is equals to sum plus j, right? As a j, first it was holding the 1. Okay, then sum will become 0 plus 1. It would be 1. Yeah, right. Yes. Then what would happen? Again, next step, 6 by 2. It's 3 times, that will result 0. Then 1 plus 2 is equals to 3. And 6 by 3, it was 2 times. Yes, that will result like 3 plus 3, that is 6. 6 by 4, it's not divisible. 6 by 5, it's not divisible. That will leave the remainder somewhere else, right? It's not 0. Okay, 6 by 6, which is not the condition of j loop, right? In a for loop, it has to less than. So up to here it's completed. That will give that. But After completion of all these steps, okay, after completion of up to the sum, right? Okay, what we have to do right now, at the final step, the sum is holding the 6, so we need to verify. How we are going to verify that, right? If if the sum what you got, and that should equals to the present of an I, that should equals to the I, then you can print that particular I. Okay, yeah, this is the code for that. Okay, if you have any doubts, just comment me below. Just open the, I mean, you can write by using the scanner class, or you can write directly by using the for loops. Okay, I have explained the problem, that is a range of prime with the both, right? Without using the scanner, with using the scanner, you can do that too. And that first, I have taken the for loop, which isn't equals to I must be less than or equals to the 100. Then you have to increment every time. Okay, if you are not aware of the for loop or enhanced for loop conditions, please go and check our previous videos. Okay, what is the first, you need to set the sum, because all it deals with the sum. And int of j is equals to 1, and j has to less than I, because exclude the given number, and j plus plus. Okay, if the number which is I, that should modulo by j, that resulted in the remainder as 0, you can set that sum is equals to sum plus j, because j is every time updating. Like 6 is equals to the factors 1 to 6, it has to check every time, and that will equals to the sum at particular case. So after that, if sum double equals to j, sorry, double equals to I, because we are running at I is equals to 6, I need to get the 6, which is sum is 6, I is at 6, right? Both should equal. In that case, just you can print the I value. Okay, if I run the code for that, it will ask 6 and 28. Okay, 6 and 28 are the perfect numbers between the 1 to 100. Okay, if I take 1000, you are going to get 628, 496 are the perfect numbers. Okay, and if I have to run the same condition, okay, if I have to run by using the scanner class, you can take like enter start number, okay, and remove this. And I have explained clearly in the prime numbers range how to do that. Here I'm directly writing the code for that. I mean, you have to take the two numbers, right, starting and ending numbers. So I was taking that, then int of n, or you can sc dot next int, right, next int, you can take that, and with the semicolon control 1, you can say like it's sent. Yeah, it was asking the starting number should be 1, so what is the starting number instead of 1, it has to take start. And what is the ending number, you have to update with the end, the user enters with the same code. Okay, if I run the code, what it will give, right, it was entering the starting number 1, 100 is the ending number, you are going to get two factors. Okay, if I rerun the code, if between 1 to 1000, you are going to get the perfect numbers as 3. Okay, and this is the code for the perfect numbers. And up to here, for loop problems is completed successfully. If you have any doubts, if you have more problems to explain, just write in the comments the problem name, and I'm going to explain that by using the try run and everything what it's required. Next, we are going for the pattern programs, which are very important for the logical building. And up to here, you have, if you have watched, just subscribe to our channel, like, share. Thank you for watching.